We are in the renal cortex, and the way we know we're in the renal cortex is because it's very convoluted. It's got the twisty-turny convoluted tubules, and it's got the renal corpuscles. These nodular structures are the renal corpuscles. And everything else are the renal tubules. So let's go up in magnification. And so this is a convoluted tubule, and this is a convoluted tubule. One of them is smoother lined, one of them is rougher lined. One of them is proximal, one of them is distal. Do you have to differentiate proximal from distal convoluted tubules? If you're reading, it says you don't, okay? So you just have to know that these short oblique and transverse sections are convoluted tubules if we're in the renal cortex. This is a renal corpuscle, and you can't separate the glomerulus visually from the visceral layer of the Bowman's capsule, but what you can do is you can see the parietal epithelium opposite the capsular space from this central mass that includes glomerulus and the podocytes. So the parietal or capsular epithelium is fair game. I would look around and find a better one where you can clearly see some of those really squashed nuclei of the simple squamous epithelium. Okay? Then I'm going to go back to low power, and we're going to scan down and watch the tissue change before the actual round thing. Was that the corpuscle on the previous slide? This whole thing is the corpuscle. It includes the outer parietal layer and the glomerulus with the visceral layer. Okay? So as we scan down, we end up with a very different looking kind of tissue. Down here, we do have some cuboidal epithelium, and we have some squamous epithelium. Well, we have thin limbs and thick limbs, descending limbs of Henle and ascending limbs of Henle. We also have collecting ducts, and I'm not making you differentiate. So here's a place that's on its way down to the renal papilla. And the bigger lumens would be collecting ducts, the narrower lumens would be limbs of Henle. But I'm not making you differentiate. You have to be able to tell me it's one or the other. And there is a renal papilla. Okay? So the layer name here is renal medulla. The structure name is convoluted tubule and or collecting duct. And take a look at that. And we'll fast forward to that. Quite a different appearance. You can find a place where you have not just longitudinal sections, but a lot of cross sections as well in the renal medulla. So that's the kidney. We have a section of the kidney that you can also study. Another slide there. I'm going to show you the ureter. We have studied this slide before. This is the slide with the starfish-shaped lumen. And I'm going to go to low power. It's lined by our infamous transitional epithelium. And that transitional epithelium with a thin layer of connective tissue forms the mucosa. Deep to the mucosa is smooth muscle tissue. And it is presented in sublayers, two sublayers. We're not necessarily recognizing them or studying them, but in order to affect peristalsis, it has to be. this ureter, we can get the entire thing in our field of view at low power. Now let me show you the urinary bladder. It's not possible with the bladder to get a full cross-section, even of a small mammal bladder. So I'll go back to scanning power. I was on low power of the other one. So this is even lower scanning power. And here we see a lot of folds of mucosa and submucosa. These folds will flatten out when the bladder distends. So what's the name of a temporary fold that flattens out and reforms with distension? Arruga. So this is arruga in the urinary bladder. Here is arruga. Here's another arruga. Folds. Okay? Now, if we go up to at least low power, we can start to recognize the transitional epithelium, and I won't make you differentiate the lamina propria from the submucosa. That's kind of a subtle difference. But as we get deep to that submucosa, we pick up smooth muscle. And this smooth muscle is not called a muscularis layer. It's very thick, it's very complicated. Fibers run in 3 planes, circular, longitudinal, and oblique, and they form a very robust muscle that effectively works to squeeze the bladder and completely void the urine. Okay? So what's the name of this muscle? The detrusor muscle. So we don't call it muscularis layer, we call it detrusor muscle. If I ask you to name this layer, it's the detrusor muscle. Okay? And that's all on the bladder.